in probability, why people are joining so late? So a random variable is a variable whose value depends on the variations due to chance or probability. So it is basically a random function that allots a real number value to a given sample space. Suppose getting head or tail. So if we are assigning a value of getting head is 1 and getting tail is 0, then the real number 0 and 1 will define are defining the probability of getting a head or a tail. So in this case, the probability of 0 or probability of 1 are 1 by 2. In the similar fashion, if we throw a dice, then getting a 1, 2, 3, 4, 5 or 6. For each value we can assign a real number. It can be again 1, 2, 3, 4, 5 and 6, because this is discrete random variable that we will see in the later slides. What is the difference between discrete random variable and continuous random variable? So in that case, again, the probability of occurring of 1, 2, 3, 4, 5 or 6 will be 1 by 6, 1 by 6, 1 by 6, 6 times. So the total probability of getting all these number will always be 1. So random variable is a real valued function on the set of sample space by a distinct corresponding rule that assign a real number to every point on the sample space. So every points are each outcomes. So a random variable actually assign a probability, a real number to every outcomes. Now types of random variables. Function of random variable which takes individual isolated values like 1, 2, 3, 4, 5 or 0.1, 0.2, 0.3, 0.4. It will not be continuous in that sense. It's like height of a person, weight of a person. So those variables that take individual isolated values of variables, those are discrete random variable. But the function of random variable which takes values in a continuous interval, those are continuous random variable. Examples can be when we evaluate our grade system. So if you are scoring 40 to 45, then it will be B. It will be B grade, that is 9 pointer. So if you fall in that range, 40 to 45, so that is representing a continuous random variable, 40 to 45. So in that case, you are getting a 9 pointer. So that's the basically difference between discrete random variable and continuous random variable. That discrete random variable takes individual isolated values, and continuous random variable takes values in a range, in a given domain or in a given range. And mixed random variables, the variables which takes both continuous and discrete forms. Now probability structure, a probability distribution function. It basically represents the probability of the random variable, of the assigned or the allocated random variables. So it's a mathematical function that describes the likelihood of obtaining a possible values that a random variable can assume or take. That's the domain of the function. Probability distribution function for a given experiment is expressed mathematically as a function of random variables. It is represented or denoted by f of x, small f of x. Just remember, in case of probability distribution function, we will use small f, and in case of probability cumulative distribution function, we will use capital F. CDF is capital F and PDF is small f. So probability distribution functions are further classified as probability mass function or probability density function, depending on the random variable it takes. So the probability distribution function that corresponds to a discrete random variable, which takes individual isolated values, is known as probability mass function, and those value which takes in a range is known as probability density function. So we can see the example here when a coin is tossed, and of course I do not need to tell that the characteristics of probability distribution functions, whether it's a mass function or density function, whose value lies between 0 to 1, and the sum of all value will be always 1. Then probability density function fx, it corresponds to the continuous random variable. Suppose in this case, I'm sorry that the formulas are missing, but what we are doing in this case, we are integrating. We are integrating the value 0.1 minus x by 1800 in the range of 8200. In the range of, see, it was given what is the probability that a current measure is less than 90 milliampere. So we will evaluate in the range of 80 to 90. And if you will evaluate in the range of 80 to 100, you will get a value of 1. Why? Because the total probability will always be 1. So I'm repeating these two questions again. When a coin is tossed, then the inputs of the functions for the random variable are head and tail. So head and tail are the values in the sample space, and we can assign two different values, 1 and 0 for head and tail, and whose probability will always be 1 by 2. Or we can simply remain it h and t, head and tail. And in this case, where the continuous random variable denotes the current measured in an intrinsically safe equipment in milliamperes. Now, intrinsically safe equipments are those equipments which has some restrictions that the current will not exceed a particular given, so that there will not be any misfire, or it will not ignite any gases that can be like methane. It just needs some amount of ignition and it can blast. So intrinsically safe equipments are those equipments. So in this case, we have assumed the range of 80 to 100 milliampere and have assumed the probability density functions of 0.1 minus x by 1800 in the range of 80 to 100. So what is the probability that a current measure is less than 90 milliampere? Is 19 by 36. You can integrate this equation and you can find it out that what is the probability that current measure is less than 90 milliampere. So cumulative distribution functions are those functions that represent the total probability distribution up to a given point of random variable. Is also known as distribution, simply distribution function or cumulative distribution function. It is denoted by capital Fx. So, wait a minute, I'm having some problem in the slides. Yes, so you can see in that presentation the formulas for discrete random variable and continuous random variable that correspond to probability mass function and probability distribution function for distribution function. In case of discrete random variable, we are using summation sign, and in case of continuous random variable, we are using integration. Now these values represents mean or the expected value and variance of the random variables. We can see the formula is simple. E of x is x of fx for all x. Similarly, in case of continuous random variable, it will be minus infinity to plus infinity x of fx. And variance is x minus mu whole square into x of fx. In case of discrete random variable, there will be summation. In case of continuous random variable, there will be integration. So these are some spatial probability mass function that we might need to deal. Discrete uniform distribution. For n number of division, the value, the probability function will be 1 by n for all n. Its mean will be b plus a by 2, and variance will be b minus a plus 1 whole square minus 1 by 12. So you can see these things, these formulas. I will send you the PPT as well. If you want to see its graph, then I can show its graph also. See, when a dice was rolled, it's the probability mass function. It is one of kind of discrete uniform distribution. Probability Bernoulli's distribution. When there is only two kind of event that can happen, success or failure. In that case, we use Bernoulli's distribution. Binomial distribution. In the later stages, we can see that Poisson distribution is the is a special form of binomial distribution when n tends to infinity. So this is what we were discussing, different kind of distributions. Now this is that current problem example, and this is its graph. Probability of getting current less than 90 amperes. Then you can see exponential distribution function, gamma distribution, and this normal or Gaussian distribution function. This is the very important distribution function with respect to our statistics, because we will study a central limit theorem just after this, and we can find any random variable will can behave like normal distribution function when n tends to infinity. And these are different forms of normal distribution function or different value of mean and variance. Now, linear combination of random variables. So we have seen the linear combination in matrix, in vector, and now in random variables. That is why linear combination was always, I told you it is very important. So again, like vector, for any given random variables x1, x2 up to xp, if there exist constants c1, c2 and so on, then the linear combination will be simply y equals to ci xi summation over it. And its expectation will be again ci e of xi summation. And similarly, the variance will be ci square v of xi. And if you will break the variance, then you will also find a term covariance that represents or that measure the linear relationships between two variables xi and xj. It is also known as covariance. So for two random variables, covariance is calculated as expectation of x minus mu x into y minus mu y. That is the expectation of xy minus mu xy. That is the multiplication of their mean value. Now, if the random variables x1, x2, and so on are independent, then sigma xi xj will be 0. And so, when they are independent, then their product will be 0. And finally, you will get the covariance is 0. And then again, there is a term correlation between the random variables. It is defined as covariance divided by square root of variance. Please look at these formulas once, all of you. Okay, then central limit theorem that I was discussing before. And it simply states that if we add a large number of mutually independent and identical distributions, then sum can be closely approximated by normal distribution function or the normal density. Mathematically, it can be represented as Zn, which is the sum of these random variables. Sorry, Zn is not the sum. Y is the sum. So that Zn will be a standard normal distribution function when n tends to infinity. And for any interval, if n tends to infinity, it will behave like a standard normal distribution curve with mu equals to 0, that is mean value, and sigma, that is the standard deviation, will be 1. So the interpretation or application of central limit theorems. See what normal distribution this central limit theorem is doing basically. It is characterizing when n tends to infinity that we had seen in that problem. We had we did our experiment for 30 samples, for 50 samples, and then we repeated it 1,000 times. So the value was changed. For the same problem, the value became 74.54 from 74.32. It is because of central limit theorem, because we repeated it 1,000 times. So we will again do the coding on that. So interpretation or application of central limit theorem in a series of repeated observation, the precision of the approximation improves as the number of observation increases. So when the number of observation is increasing, we are getting less biased data basically. So when we are getting less biased data, its precision is increasing, and it follows a specific density, specific density function, which is normal distribution function or normal density function. So the simplest form of the central limit theorem states that sum of n independent distributed random variables will tend to normally distributed as n becomes large. Okay, you can look at this problem. And after this, we will start our coding session. So you people can open your Jupyter notebook after this. And then we had seen that there can be relationship between two events. So what are the random variables? Random variables are basically a form of events in which we are expressing it numerically. So by that, we can measure if there is any linear relationship between these two random variables or not. Because if there is any linear relationship between these two variables, then the outcome of one will affect the outcome of other. So any doubts, anyone yet? We can resume with our last program to find out the central limit theorem, and the coding was given to you. So otherwise I'm again pasting it. You can use this code.
We will check whether all means are. Hello students. Hello student, this is Manoj. Now we will run a test in which we will test that our data which we have plotted here, it is a histogram showing which is we have produced by determining the means of 1000 samples and then plotted it whether it is followed a normal distribution or not. For this there is a theorem known as Spiro, and it basically will be given in the SciPy stats library. So firstly we have to call our library named scipy.stats. So here only I am just starting from scipy.stats import Spiro. Sapiro, SHAPIR. So this is a type of test which will determine that whether we have done this type of distribution, we have plotted whether it is normal distribution or not. Now this will produce two variables, stat comma p. This is a function. We have import the library Spiro, and from that we are using a function Sapiro, and it will give us two variables, stats comma p. In 1 minute I will show you I will tell you what is the significance of those parameters. When statics So what this statics is a character, and this curly braces will give us values, which will I write here. Dot format is our function, and it will type the values of stat comma p. Now we will here is a requirement that we have to determine our confidence level, which is known as alpha. We are saying it here alpha in this theorem. 0.05 means it is saying that our confidence level is 5%. Now what there are two statements. I am stating by them is condition if P is greater than alpha. Alpha is our confidence level. Then print sample looks normal. So here we have to write, in the morning session you have studied about the hypothesis. So here we are also using a null hypothesis here, which say that if it is normal, then we will say that we accept the hypothesis. So we are saying that do not reject null hypothesis, which means that if it is a normal, it will not reject hypothesis. Else sample does not look normal, reject null hypothesis. So if I run this code, so here we can say that we can be seeing that here below statistics is 0.998 and p value is 0.42 in significant terms. Now what this significance terms? It is saying that it is means reaching the normal distribution. So its significance level, or you can say that it is reaching 42% to the normal distribution. So if it is greater than the confidence level, which we have considered 5% initially, so 5% confidence level is very low. In data science, at least 95%, 99% confidence level we require. So it is much greater than this value, our p value, which is determining us the significance of this normal distribution. So in also if it is showing that if it p is greater than confidence level, it will be look like a normal. So we can see also here by our visualize that it is a normal distribution. So by using this means the whole central thing is that firstly we have determined the means of our sample, means we have taken the weight of the person 50 persons in between the 60 and 90 range. Then we have determined the means, and then in means we plotted this curve, and after that we run a Shapiro theorem which gives us a p-value significance value which is greater than the confidence value, and this will tell us that it is look like a normal, or it follows a normal distribution at 99% confidence levels. So also similarly you can determine means further probability density functions. So in our next class we will tell how you will plot the probability density functions.
So anyone having any doubt? Anyone? Doubts related to this?
Here alpha is the confidence level. So means it is
Confidence.
confidence. It is basically the confidence level. So if confidence level is means we take higher, then what is the meaning of testing it? So we are taking very low value, means 5%. You can take 0% also. You can take 10-20% also. So based on that, you can change this value, and if it is means basically the whole thing is that our p should be greater than alpha. That is the whole thing to say.
Okay, Abhinav, clear? You can run different programs.
Okay, now you can try at your home that if you take the sample size of 100 and then run this code and also increase the range of weight. So say if you take the so here you take the random variable from 50 to 100 and also that thing to be 90. In 90 samples you take and run for 200, then what will be this diagram will be look like. So you can manually, means it is very simple, but just change in the code and give us the values of p and statistics. These two values you can give us.
So you can try this. Now everyone can fill their attendance in the forms in the given link in the chat box. So people can leave, accept batch one. Batch one, please be here. So we will meet tomorrow. People can join their respective batches and fill the attendance in the form. Once the module will complete, I will send you the notes. Let this module will complete mathematics, then I will send you the notes of mathematics. So batch one, anyone want to ask any question further? Or or you people want to say anything related to the course? If it's going if it's going too fast, or and getting it or not? Anything related to the course?
Sir, in Jupyter related practical, we are getting problem.
Ask. You can share your screen also, Ranjan. See, you practice all those codes which we are performing in our lab sessions. You can also practice in
Yes,
uh,
but there is
Google
a
Colab.
lot of new words coming in this Jupyter, so that's I'm not getting.
Actually, you need to be yeah. You need you can Google means mostly you need to get familiar with the commands with the different function and the commands which we are using in the Jupyter notebook.
Right, sir.
And I understand that we are not from coding background, so we need to, but we need to be familiar with these codes,
Right, sir.
and eventually you will learn all these things. As the time will pass, देखते देखते तुमको सारे कोड्स पता चल जाएंगे, and it will not be tough.
Yeah, right, sir. Sir, for example, for in import, we are getting that we are using the sharp hero. So why we use this word? So that's the thing.
See, the sir has already explained. Yeah.
So this command basically people used to, if whatever plot we have done above, so by collecting all the plots in just one plot means combining the merge the plots. Yeah, hold on. In MATLAB you have seen hold on command means if two you have plotted two, then the next plot will be override the other plot. So generally, if we can't write a here, but still for the safety purpose, we write key with both hold. In yesterday class, your day before yesterday class, as I print sine x curve, then after that I print cos x curve. If I have to combine or merge or so in only one axis, then I have to write that. So
Right, sir.
basically it works as a hold on command.
Yes, I got it, sir.
Okay, hold on. If you search on hold on MATLAB or some study, then similar to. If you don't write, then no problem. But you just means shut down the command, then again on the command, then you see means which command are important or not. In this way, you can play or learn more.
Sir, when we are getting the results, so in some of the cases, like error is showing. So in that, which types of error is showing? So
Yeah, if error mostly the syntax error they so if you have seen or some if you does not given the proper inputs indentation error are there. So majorly what you are means what type of error mostly it is showing.
You can also email the screenshot of your error if the after the session also. If you're running your program after the session, you can send the screenshot so that we can check and we can tell you.
right, sir. Yes, sir, I
No
got it.
problem. You can just means,
Yeah.
share your problems and
Share your screen whenever you get a problem. If we are running on the session.
or in the means, after the session you also mail the in groups or somewhere.
Yes.
I'm facing this problem.
Yes, sir.
Okay, Ranjan.
Yes, sir.
Okay. So everyone has filled their form, attendance. Okay, then we can see, we can meet tomorrow. We'll start our session tomorrow at the same time, 10:30.